Okay. Everyone tell me once again what are the 4 conditions we discussed? Okay, wait. A compound to be aromatic, it should be cyclic first. Then next it should have plenarity, complete conjugation, 4n plus 2 pi electrons should be there. This many pi electrons. N value can be 0, 1, 2, so on, like this. If you put 0, you will get 2 pi electrons. If you put n equals to 1, you will get 6 pi electrons. Next, if you put 2, you will get 10 pi electrons, like this. Like this, electron count will be there in aromatic compounds. Okay, right. Now, yesterday I have given those examples. You can try them once again. Okay. Then next here I will be giving 1 or 2 example for understanding purpose. What about these 2 compounds AB? Which is aromatic, which is anti-aromatic? Tell me out of these 2 first. What about the first one? Cyclic, both compounds cyclic. Next, plenarity means it should either have sp or sp2. Sometimes there will be sp3 carbons also, but they won't participate in this conjugation, they won't disturb this conjugation. So that compound is also aromatic. Okay. So mostly it will be what? Either sp or sp2. Next, see all carbon, see at least 1 pi bond is there, means definitely that carbon is sp2. Next, what about this one? Carbocation means definitely this carbon also sp2. Okay. Now what about these carbons? All carbons, see here 4 carbons are sp2. Even if it is participating in the conjugation, now what happens? This negative charge become a pi bond. It means this carbon also sp2. So all carbons are sp2 here. So plenarity is there, cyclic compounds. Complete conjugation is there or not, once check. See, pi bond, like a sigma bond, vacant orbital. Like this, if it is shifting, pi electrons, see, like positive charge means what? Electron deficiency only, no? It means here we have vacant p orbital. To that vacant p orbital, these electrons are shifting. So which carbon is losing that electrons? The top carbon, this carbon, right now. So positive charge should be written here. So you should write the conjugative structure like this. If it is shifting here, positive charge comes here, like this. Is this clear? Again, next once again you shift this one now. Where I should write the positive charge? Here, right now. Like that, complete conjugation is taking place or not? Yeah. So if complete conjugation is taking place, yeah. You can say either it can be aromatic or maybe what? Anti-aromatic. We'll check once. Okay. Now again positive charge here. See, it is very simple. You need to understand that when there is a positive charge, pi bonding is shifting towards positive charge. Endukante positive charge is nothing but vacant orbital, no? So to that vacant orbital, pi electrons are coming. Remember this. Okay. See, again this will be shifting here, like this. See, first I started here, then I started with this one, then I am like moving like that. It's going like a circle, na? Complete conjugation is taking place. Now if you see this, when there is a negative charge means there is no vacant orbital here. Negative charge means electrons are there in the orbital. Now when negative charge is there, you start conjugation from that negative charge. ఇక్కడ పాజిటివ్ ఛార్జ్ ఉన్నప్పుడు ఏం చేసా, వేరే దగ్గర నుంచి పాజిటివ్ ఛార్జ్ ఉన్న కార్బన్ వైపు తీసుకొచ్చా. ఇప్పుడు నెగటివ్ ఛార్జ్ ఉన్నప్పుడు ఏం చేస్తున్నా, యూ స్టార్ట్ కాంజుగేషన్ ఫ్రమ్ నెగటివ్ ఛార్జ్. సో నౌ వాట్ హ్యాపెన్స్, సి ఇఫ్ ఇట్ ఈస్ షిఫ్టింగ్ దిస్ సైడ్, ది పై ఎలక్ట్రాన్ విల్ బి షిఫ్టెడ్ ఆన్ టు ది కార్బన్ హియర్. Okay, now you can write a positive charge or negative charge here like this. Done. Next what we can do, again from where I should start? Negative charge. So this side now, don't go back side, already we came from back side only. If you go back side again you will get the first structure. Go front side, this side. Now this will move towards here, right? Like this. Like this. Next here negative charge. Okay, again it will come here, again this will goes here, like this. Complete conjugation is taking place. Perfect. Next one, 4n plus 2 pi electrons I am saying. See, you put n equals to 0, 2 pi electron. How many pi electrons are there in this first system? Positive charge means 0 electrons here, no pi electrons. But here 1, 2, 3, 4. So 4 pi electrons here. What about this one? 1, 2, 3, 4. Again negative charge also becoming a pi bond. So 1, 2, 3, 4, 5, 6. Negative charge means 2 electrons. So total 6 pi electrons here. So which is having this number? 6 pi electrons means second one. So second one I can say it is a aromatic. What is the second one is what? Aromatic. Now first one, see, following first condition, the A compound following cyclic first condition, second condition, third condition, but this last fourth condition is there now. Instead of following this, it is following something like this, 4n pi electron rule. 4n pi electron rule. Put n equals to 1 now. 4 pi electrons. So by following first three conditions, along with this you should say it as anti-aromatic. What is it? Anti-aromatic. Okay, if none of these rules are followed, then that compound is non-aromatic. Everyone clear with this? Yeah. Now what is the use of studying this? Means the compounds which are following aromaticity, or compounds which are aromatic, are highly stable. What I am saying, stability is for which one is highest? Aromatic compounds. Next one is non-aromatic. Non-aromatic. And the least stable or highly unstable is anti-aromatic. Which is highly unstable? Anti-aromatic compounds are highly unstable. Is this clear everyone? Okay. Now see, aromatic, non-aromatic, anti-aromatic. Who is stable? Aromatic. You might having, sir, why aromatic compounds are stable? Like this you might think. See, one is conjugation. Sir, anti-aromatic compounds also have conjugation, but you are saying these are stable because we studied molecular orbital theory. Do you remember? Yes. There we have filled molecule like bonding molecular orbital electrons, the next anti-bonding molecular orbital electrons. Do you remember? Like sigma 1s, sigma star 1s, like this we filled right now. See, when we are filling electrons in bonding molecular orbital, its bond order is getting increased. Yes or no? What happens? That molecule will exist. See here 2 electrons are there, anti-bonding 0 electrons are there, means bond order become 1, that molecule will exist. But if you fill in anti-bonding molecular orbital, what happens? Bond order, see here 4, here 4. Bonding minus anti-bonding, 2 minus 2, 0. If bond order is 0, will that molecule exist? No. So whenever you are filling in anti-molecular orbitals, like anti-bonding molecular orbitals, that molecule becoming unstable, or that molecule won't exist. So when I am saying aromatic compounds, all the like nth level electrons will be there, na, that valency electrons. All those electrons are lies in bonding molecular orbitals. In which orbitals? Bonding molecular orbital. For example, here I have given you one structure. Otherwise, let us say this is our benzene. Benzene means I should write like this. Okay, so normal molecular orbital diagrams means like we'll write sigma 1s like that for normal molecules like N2, O2 like that. When it comes to aromatic compounds, you should take something called Frost-Muslin rule or polygon rule. What is that concept called? Polygon rule. So here you just take this polygon. See, I am writing hexagon structure or pentagon structure or something like this square structure or something like this we are drawing now. You put these polygons in the circle. What I am saying, you put these polygons in the circle. See, for example, I want to put this. So you try to attach these corners to the circle. Like this, like this, like this. Okay? After doing like this, at each corner, like divide this molecule into 2 equal halves like this. Okay? Now, here one carbon is there, there one molecular orbital. Here one more molecular orbital. Here one more. Here one more. Here one more. Here one more. Okay? Like that 6 carbons are there, 6 molecular orbitals I have taken. How many pi electrons we have? 6. See, this is the energy order. It means this is the lowest energy, little higher, more highest energy is for this one. Like this energy coordinate. So first we need to fill electrons in the lowest energy now. So fill here. See, in one orbital how many electrons we can fill? 2 electrons, done. Okay, next one, if you observe this molecular orbital are having equal energies. So here one, here one. Like that, how many electrons we have? 6. So 2 over 4, 3, 4. Degenerate state na, one here, one here. Next, fifth one here, sixth one here. All over. Okay. Now see, this horizontal line is there na. Below that horizontal line, whatever the molecular orbitals you are seeing, those are called bonding molecular orbitals. What I am saying? Those are? If in case some compounds will be having molecular orbitals exactly on the line. If they are exactly on the line, they should be called as non-bonding molecular orbitals. What they are? Non-bonding molecular orbitals. Any orbital which lies above this line will be called as anti-bonding molecular orbitals. So now for aromatic compounds, all pi electrons lies in which orbital sequence? Bonding only. So if they are lies only in bonding, they are stable now. That's why aromatic compounds are stable. And one more thing, all electrons are paired or unpaired? Paired. Do we have any unpaired electron? No unpaired electron means aromatic compounds are what? Diamagnetic. What they are? Diamagnetic. Sir, when it comes to anti-aromatic compounds, after filling, that electrons goes to anti-bonding. So for anti-aromatic compounds, that pi electrons will lies in which orbitals I am saying? Anti-aromatic, anti-bonding molecular orbitals. That's why molecule become unstable. Unstable for which case? Anti-aromatic. That's why. In between we have what? Non-aromatic. So these are stable, these are intermediate, these are unstable. Okay. Now I am saying these are unstable now. If something is unstable, will that process is difficult or easy? Here you are standing in a comfortable position. Now I am pushing you to some uncomfortable position. Will you go there? No. It means a molecule is here stable. If it is moving forward, this is a very unstable place. Will it go from here to here? No. No, right? Okay. See, a molecule is standing here. Okay. This is anti-aromatic, unstable. That's why molecule won't try to go for anti-aromatic conversion. But here I am writing one more position. This is aromatic position, which means stable position now. Now this molecule will tends to go to aromatic. Do you got this simple way of understanding? Okay. Why I am explaining this means, you just check now what is our chapter I am starting now? Haloalkanes, next chapter is. There you have many reactions like substitution reactions and all. See, just observe this, what I am writing. They will give like this. Now they will ask us for a reaction like aqueous KOH they will mention. What is the product formed or whether this reaction takes place or not, they will ask. How you will say this answer? See, what process it is taking place, tell me. See, we know like what is the reactive site in this compound? Like this chlorine is there now. So this chlorine will come out because electronegativity difference. That is a general approach we have. Yes or no? Yeah. So if it is coming out, what is the charge you are creating on the carbon? If it is a positive charge, write that species. Like this you are writing. So tell me, if I remove this chlorine, after removal of chlorine only this OH minus come in and that will be attacking here, right now. But for insertion of this should go out. If it is going out, this kind of fragment you are getting. So tell me, what is the nature of this compound or this fragment? This is anti-aromatic now. Anti-aromatic means stable or unstable? Unstable. Unstable means will it form? No. If it is not forming, will the reaction takes place? No, that's it. This reaction won't take place. How simple it is? Do you got the concept now? Okay. Now let us solve one direct question without starting anything from the chapter. Directly moving for the questions based on aromaticity. Okay. Now look at these questions. Ease of ionization, once again read the question. Ease of ionization to produce carbocation and bromide ion under treatment of Ag plus ion. See, simple, there is Ag plus ion. If I treat this with some like chloride ion, what happens? Like NaCl if I treat, what happens? Ag plus Cl minus forms AgCl as a precipitate. Right now, similarly if I treat with this NaBr, AgBr type of precipitate will be formed. Yes or no? Yeah. So same story, they are asking us to treat these 4 compounds with what? Ag plus ion. Now all of them are having commonly what things? Bromine. So this Br minus Ag plus forms as AgBr. Now they are asking which of this compound easily forms this AgBr precipitate. It means what is the thing you need to consider now? You just need to remove this Br minus first. Right now, after removing Br minus, what is the thing here? Positive. If it is positive, what we need to check for? Aromaticity. If it is aromatic, reaction will proceed. If it is anti-aromatic, so tell me whether this reaction, whether this precipitate is formed or not? No. Why not? So it will not undergo reaction. Is this clear, everyone? Okay. Now they are asking, see, ease of ionization to produce carbocation. It means if one of this compound, after removing bromide ions, if they become more stable compound, that reaction takes place. Now try to remove bromide ion from all these compounds. Now check once. Which compound will become aromatic after removing bromide ion? So if I remove second one from here, so what is this charge? Positive. See, now check for compound is cyclic. Next, all carbons, oxygen, everything is planar. Okay, now how many pi electrons are there? You check. Array. Be conscious. Here oxygen have lone pair now. Sir, 2 lone pairs are there now. I should count this one, this one. No. On an atom, only 1 lone pair should be considered into the conjugation. How many lone pairs are there? No matter. How much we should consider? Only 1 lone pair from 1 atom, from this oxygen atom. Here one more oxygen atom means there also you consider 1 lone pair of electron, that's it. Okay, so 1 lone pair here, it means 2 electron, 3, 4, 5, 6. 6 pi electrons, aromatic number. Okay, 6 pi electron, complete conjugation, all rules are followed. So this is becoming aromatic after removing bromide ion. Yes or no? So this compound ionization is easy. Will you agree with that? Yes. So which is easy for ease of ionization, which is easily forms AgBr precipitate? Second one. So now what about third compound? See, already bromine is there means actually it is not about bromine. Actually this compound is aromatic. Right now, this is aromatic and this lone pair electrons are there now. These are playing like they are in conjugation with the pi electrons. If they are conjugation with the pi electrons means a single bond becoming pi bond, double bond. Will it come out? No. No, this is also won't get precipitated. Okay, now what about this compound? Yeah, so if I remove this, there is nothing like aromaticity here. Okay, but if I remove this, what happens here? Positive charge will be formed. Yes or no? What about that positive charge? In the last 2 classes, before last 2 classes, I told you something like allylic, benzylic. Do you remember that concept? If I remove this bromine, now what type of system is forming? See, pi, sigma, plus. Alternate position now, this bond can shift here. Only one pi bond is there now. With conjugation, you should say that system as allylic system. What is that system? Allylic. So allylic carbocations are stable by conjugation. So it means out of these 4 compounds, which of them will be possible to formation of precipitate? 2 and 4. But out of 2 and 4, which is more stable? 2, because it's aromatic. This is non-aromatic. We know stability for aromatic is more. That's why 2 first, then next. Is this clear, everyone? Yeah, fine. Next, let's start our discussion on, okay, see, whenever you are solving organic questions, now itself I am saying, we have very less time, that's why. Whenever you are solving some questions, if you see something like rings, pi electrons, conjugation, okay, if they are asking about any reaction, try to use aromaticity concept there. If any possible way is there means what you need to check? Aromaticity. Most of the questions will be sorted from that. Okay? Yeah, next. Again, we'll come back to the questions later. Once we'll finish this chapter, we'll come back. Okay. Okay. Haloalkanes Haloarenes. See, at least, see, Cn H2n plus 2. This is alkanes formula now. This is alkanes formula now. From this, I am removing one hydrogen. It means X I am writing. For example, C2H6 is there, ethane. From ethane I am replacing one hydrogen with halogen, C2H5Cl, ethyl chloride, ethyl halide. Like that we are getting our what? Haloalkanes. Okay, now what about haloarenes means? Arenes means like benzene ring is there now, this is called arene. Okay, so now what is the general formula? C6H6. Now from here also you replace at least one hydrogen with chlorine or any halogen. For example, I am replacing this hydrogen with you take any halogen here, then it becomes aryl halides or haloarenes. What they are? Haloarenes. Okay, now when it comes to their IUPAC nomenclature and common names, the common name of this compound, like I am saying, common name also called as trivial names, you should call it as ethyl chloride, like alkyl halide. Common name is what? Alkyl halide. When it comes to IUPAC name, you should call it as haloalkane. What is that? Haloalkane. Like chloroethane. What is this? Chloroethane. So you got two names now. Common name, what is the general name? Alkyl halide. What is the general name? Halide. IUPAC name? Haloalkane. Haloalkanes. Next one, like chloroethane. This is the IUPAC name. Here, okay, you just say chlorobenzene. What is that? Like halobenzene. So like this, like chlorobenzene, bromobenzene, fluorobenzene, like that we should call. Okay, done. Up to here it is done. Next, let us enter for the reaction. See, preparation methods now. How can we prepare alkyl halides? So try to summarize the reactions like this only in your notes also if you wanted to write, but don't take too much time. If you want to take time, you can write later. Okay, yeah. So see here, what I have mentioned here, alcohol. So first preparation method is from where? From alcohols. Yesterday we have discussed about what reactions? Hydrocarbons. There I told you like how to preparation methods of some compounds are nothing but chemical properties of other compounds. Now here preparation methods of halogens, alkyl halides, is nothing but chemical property of alcohols. Okay, like that you can remember. See, alcohol, see what I am doing, just check ma. Alcohol I have, I am treating with HX. HX is nothing but like HCl, HBr, like that you are treating. We know HCl, HBr, all are this what? Acids. Okay, so acids provide H plus, that H plus is taken by OH, comes out as a water, and that halogen and this alkyl group forms that respective product. Clear everyone? Okay, once again I will tell you here. Ethyl chloride is there, ethyl alcohol is there. I am treating with HBr. Tell me what happens here? Ethyl bromide. So remove this as a water, ethyl group, bromide. That's it. Is this clear? Easy to understand. Like that, first reaction is done. Next one is, you take any you take alcohol, treating this with like PCl3 or PBr3, like this we will take. So let us say I am treating this with PCl3. To avoid confusion, I am taking only PCl3. See, just give this OH to the phosphorus, that chlorine to the alkyl group. So now what is the product form? RCl. Like that, how many chlorines are there? 3. So each chlorine give here OH you take. It means one molecule contains how many chlorines? 3. So one PCl3 react with 3 alcohols. So you will get 3 products. So to phosphorus what you are giving? OH. How many OH you are giving? POH3. This one can be written properly as H3PO3. This is called orthophosphorus acid. Okay, they will ask what is the byproduct formed also. Okay, and they will also ask what is a base, it's an acid or a base, they will ask. It is an acid. What is the name? Orthophosphorus acid. What I am saying? Phosphorus acid. See, here oxidation state is 3. Same here also oxidation state is 3. With this oxidation state, you should write like this structure. O, how many oxygens are there? 3. One is over here. Second one, third one. Each oxygen is divalent, so I am putting like this. How many hydrogens? 3. 2 over, next one is like this. See, these two OH group hydrogens are there now. These are acidic hydrogens. What they are? Acidic. So now what is the N factor for this acid, they will ask. Like sulfuric acid, how many acidic hydrogens are there? 2 hydrogens. So it's a dibasic acid, I can say our N factor is 2. For this also, how many H plus ions coming out? 2. So its N factor also 2. You should remember like this. Now what about this? This is not a acidic hydrogen. So this is like it can act as a reducing hydrogen. What is that? Reducing hydrogen. Just write it like that. Reducing hydrogen. Okay. Anyways, you got this chemical reaction or not? What is that? Tell me. Alcohol with PX3, like it can be PCl3, PBr3, gives you alkyl halide, like RX. Okay. Next one. See the next reaction. Instead of saying PCl3, I can also take PCl5. What I am taking? PCl5. Now what is the oxidation state here? +5. Okay. So in +5, you just remember chemical bonding. We discussed about its structure and hybridization. Tell me fast. sp3d. sp3d. In sp3d, what is the geometry it has? Trigonal bipyramidal. Trigonal bipyramidal. I told you there is axial bonds, equatorial bonds. Do you remember? So how many chlorines are in axial? 2. That axial bonds are longer than equatorial bonds, I told you. Remember? Okay. So now that axial bonds longer na. See, if distance is more, that bond easily breaks na. దూరం ఎక్కువ ఉంటే ఈజీగా బ్రేక్ చేయొచ్చు కదా. Axial bonds are weaker than equatorial bonds. How many axial bonds are there in this? Remove the 2 chlorines. Give that oxygen to here. How many chlorines I am saying? 2. Which chlorines? Axial. Remove the 2 chlorines, give oxygen. POCl3. This is the byproduct. How many chlorines you are giving? 2 chlorines now. Give 1 chlorine to the halogen because oxygen is removed. RCl. Okay. And 1 hydrogen is there. Where it is going? That H plus. How many chlorines you removed? 2. How many you used here? 1. Inkokati undiga. So give it to this one. So what happens? Now will you remember what are the byproducts also easy? Yes or no? Yeah. Now tell me alcohol with PCl5. RCl plus POCl3 plus HCl. Okay. Now what is the oxidation state? Here it is also 5. Here 5, here 5. Remember. Next thing is, in both of these reactions, mechanism followed is SN2 mechanism. What is that mechanism? SN2. I will tell you the mechanism, but you just remember them as SN2 in both of this reaction. Next one is thionyl chloride. Alcohols with SOCl2. What is this called? Thionyl chloride. Its structure is like this. SOCl, Cl. This is called what? What is the name? Thionyl. Pronounce it. What is that? Thionyl chloride. So thionyl chloride, how many chlorines are there? 2. Same. You give 1 chlorine to the alcohol, this one alkyl group, alkyl chloride is done. Next, give that oxygen to our sulfur. Already oxygen undi. 1 oxygen is there, 1 more you are giving. So it becomes SO2. Hydrogen and 1 more chlorine becomes HCl. Okay, alcohols upon treating with thionyl chloride forms RCl, SO2 and HCl. Now out of these methods, this method is best method for preparation of alkyl chlorides. Which method is best? Thionyl chloride. Alcohols upon treating with thionyl chloride, you will get the product as alkyl halides now. That is the best method. Why best method? See, when we are doing a reaction, along with our products, some byproducts also formed. Yes. I don't want all those byproducts. I need to remove them, filter out right now. So if the byproducts formed are removed easily, then that method is best. Yes or no? In this method, SO2 is a gas, HCl also gas. So these two gases goes out easily, and this liquid or whatever the product is there, that will remains in the crude, I mean the final product. So these are gases now. So gases can be eliminated easily by heating. So that's why this is the best method for preparation of alkyl chlorides from where? Alcohols. Okay. Next one. I told you here SN2 mechanism now. In SN2 mechanism there is something called stereochemistry. I will tell you stereochemistry. Already we discussed about stereoisomers. Here inversion of configuration takes place. Which configuration? Inversion. Here thionyl chloride, this mechanism is called SNI. It means intramolecular nucleophilic substitution mechanism. What is that mechanism called? Intramolecular substitution. Nucleophilic substitution mechanism. Here product configuration is retention of configuration. I will tell you all these things, just write them. Retention of what? Configuration. Okay, up to 3 or 4 over. Okay, next one is what? Same SOCl2. With the same SOCl2, what I am doing, see, same SOCl2. Along with this, I have some base here, pyridine, or any base will be used. Okay, product formed will be same, like RCl only, like RCl. Byproducts also like SO2 plus that HCl only will come out. Okay, but what is this I am using? A base is used. Here there is no base, that's why we got our acid as a product. So when I use this, it follows SN2 mechanism. What is that mechanism? SN2 mechanism. Here it is following SNI. So what is the product configuration? Here it will be inversion. It is following SN2, I am saying now. So this is SN2. So configuration becomes inversion. So I will tell you what about this inversion retention. You just write them beside those reactions. Okay. So once when I give that clarity, so you feel relaxed. Okay, what is this? Is this much simple retention inversion means you feel like that. But just hold for some time. Next one. After this, most important reaction for alcohol to alkyl chloride conversion is using Lucas reagent. What is that? So what do we mean by Lucas reagent? Lucas reagent means like concentrated HCl plus anhydrous ZnCl2. What is that? Concentrated HCl plus anhydrous ZnCl2 is called what? Lucas reagent. Okay. Now what is the use of this Lucas reagent means? What we are taking here? HCl. No? So alcohols converts into no? What ion we have? Alcohols converts into alkyl chlorides. Alcohols converts into alkyl chlorides. Now this is a catalyst here. So once again Lucas reagent is used for what purpose? Conversion of alcohols to alkyl chlorides. Okay. Now look at here. Alcohols means, like see what I am writing, a carbon. Alcohol means what? Definitely there should be OH group. Now to this carbon there might be only one carbon attached like this. What is a carbon you should call it as? How many carbons attached to the carbon? Alcohol attached, OH group attached carbon is there now. And that how many alkyl groups are there? One. So you should call it as a primary. Next one. What about this carbon? This one. How many alkyl groups are attached? So this will be now secondary. Next. What about this? 3 alkyl groups tertiary. Is this clear everyone? How to identify primary, secondary, tertiary? ఇది రాయకండి, జస్ట్ వినండి. ఇక్కడ ఇది అది కాదు. Okay. Identify. Which is tertiary. Identify alcohols as primary, secondary, tertiary. In the Okay, everyone, listen here, please. Tell me, what about this A carbon? So it is a tertiary. It is no matter how many carbons attached other side. Just to this carbon, how many are directly attached? 3. That's it, tertiary. To this carbon, this one, don't bother about this big chain. Just look at here, directly attached. One, this side. One more is hydrogen. It means what is this carbon now? Secondary. What about this one? See, 2 hydrogens are there, 1 carbon attached. So what? Primary. Clear now? Like this. So I hope you got some clarity like primary, secondary, tertiary alcohol. Same story even if I ask about halides also, like primary chloride, secondary chloride, like that if I ask, instead of OH, what we are going to have? If this is Cl, what you can say this as a primary chloride, this is a like that. Clear everyone? Okay. Next, look at this. So what is the discussion we are doing? Lucas reagent. So when we are treating with Lucas reagent, look at here. Lucas reagent, what it will be? Like HCl plus anhydrous. See, I am saying anhydrous. It means there is no water. It is pure dry one. Okay. So now what it will do is this OH and this Lucas reagent catalyst is there now. So together remove this OH as a water. So if it is removed as water, what we are going to get? Like the, let us say H plus ion is given to this. So what is coming out? See, this anhydrous form is there now. Now it get hydrated by taking OH like H2O. Now what we are going to get here? See, between carbon and oxygen, who is electronegative? Oxygen. The bonded electrons are taken by oxygen. So what charge you are creating here? So write that positive charge R, positive charge. Okay, so like this we got. So now tell me whether it is primary carbocation, secondary or tertiary. Tertiary carbocation. Same story you do with this and you are going to get R, C, H, R plus. With this R, CH2 plus. Like this we have 3 different carbocations. Tell me which carbocation is most stable? If tertiary carbocation is more stable, then reaction will be easy with which one? First, second, primary alcohol or secondary alcohol, tertiary alcohol? Which carbocation is more stable? Tertiary is more stable now. Then formation of the tertiary carbocation is easy, right? Yes or no? So, which alcohol readily react with Lucas reagent? Clear everyone? Why tertiary? Because respect to carbocation is highly stable, therefore its formation is easy. Okay? So with the Lucas reagent, what is the reactivity of alcohols, they will ask? Say, tertiary, primary. Now just imagine you have alcohol like tertiary, secondary, primary. You are adding Lucas reagent, Lucas reagent, Lucas reagent. And you just shaking like this. What you are doing? Shaking. The first one is what? Tertiary na? That tertiary alcohol gives you white turbidity within 2-3 seconds or within 5 seconds, which is giving turbidity. Whereas secondary alcohol gives you in some 5 to 10 minutes. Whereas primary, no reaction, no change. So now you just imagine which is giving the reaction very fast. Tertiary. Next. Secondary. Imagined everything is there. Okay, that's it. Okay, so what is the reactivity order? 3 degree, 2 degree, 1 degree. Alkyl alcohols. With what? Reactivity with Lucas reagent. This is the reactivity of alcohols. Everyone remember this? Yes. Okay, already it is mentioned here. Order of reactivity of alcohol, 3 degree, 2 degree, 1 degree. Clear everyone? Yeah. Next. Okay, so without wasting our time, let's move for discussion of SN1 and SN2 reactions. See, now what we got to know till now? Preparation methods of haloalkanes we studied. Okay, now let us go for discussion of chemical properties of alkyl halides, their chemical properties. Okay, see, alkyl halides like haloalkanes can be converted into alcohols. With what? To what? Converted into alcohols. Using what? aqueous KOH. Okay, so before doing this chemical reactions, chemical properties, let me explain SN1 and SN2 reaction so that you will feel each mechanism whenever I say SN1, SN2. Okay. Okay. First one here, right? SN1, SN2. Do it fast. Let us make it. See, here tertiary alcohols. Same thing, ma. It can be tertiary alcohols or it can be tertiary alkyl halides. Both the reactivity is same. Which alcohols react more readily in SN1? Tertiary. Secondary. Primary. Similarly, alkyl halides also if I take tertiary, secondary, primary. Okay? So, reactivity order. Next one, here it the intermediate is carbocation formation. Carbocation formation. So what is the intermediate formation here? Carbocation. See, I am saying intermediate formation means, see, reactants like substrate, reagent reacts to form intermediate, gives you final product. So how many steps you are saying? 2 steps. From starting material to intermediate, intermediate to final step. How many steps? 2 steps. Can I say this is a multi-step reaction? 2-step reaction means multi-step reaction. So multi-step reactions are called non-concerted reactions. What is that? Non-concerted reaction. So what is the intermediate here? Carbocation. So which carbocation is more stable? Tertiary. That's why tertiary alcohols or tertiary alkyl halides are there. Means what they will do first? They first form intermediate. Which intermediate? Carbocation. Tertiary carbocation. Then next secondary. Primary. Which is more stable? That's why tertiary alcohols, tertiary alkyl halides are more reactive in SN1 reaction. Okay. Now during the reaction we will use solvent also now. So solvent favored here is polar protic solvent. Which solvent? Polar protic solvent favors which reaction? SN1. So what does this mean by polar and protic? See, I am writing water molecule. Ma. So tell me between oxygen and hydrogen, but that bond is polar or not? Electronegativity difference is there now. If electronegativity difference is there, see partial positive charge, partial negative charge. Poles are created now. So I can say that bond is polar bond. Overall molecule is polar or not? Yes. Next one is, what is the next word you are seeing? Protic. Protic means we studied about hydrogen bond. Do you remember hydrogen bond? See, compounds which have ability to donate H plus ion for hydrogen bond formation. For what purpose? For hydrogen bond formation. See, this hydrogen is positively charged now. So it means it can form hydrogen bond with another electronegative atom like water molecule, oxygen, or anything you can take. So polar protic solvent best example is what I am saying? H2O. Okay. Next one here. Okay, up to here it is fine. What is the intermediate you are saying? Next one, there is something called stereochemistry. Again, the product stereochemistry here is observed as racemization, or you can also remember it as partial racemization. Sometimes it is mentioned as partial racemization. You can write this properly. Okay. Next one, here SN2. That first one is, what is the order? You are seeing 3, 2, 1. Reverse of it. 1, 2 degree. This is the reactivity order. Okay. It means which alcohol is more readily undergo SN2? Primary alcohol or primary alkyl halide. Next one, there is no intermediate. No intermediate formation. It means you are going to see a transition state. What you are going to see? Transition state. Next, here what is the solvent there I have mentioned? Polar protic. Here polar aprotic. What is that? Polar aprotic. So what do we mean by polar aprotic? The first word is same, polar. Here also polar. The bond should be polar. Aprotic means hydrogen bond donor should be there for hydrogen bond formation between the solvent molecules. Aprotic means no hydrogen bond. That's it. What is the best example means acetone. Acetone, how it will be? See, between carbon and oxygen, bond is polar or not? Like electronegativity difference is there. So polarities are generated like this, negative and positive charges. Yes or no? Yeah, this is fine. But there is nothing to donate or form hydrogen bond. Like hydrogen bond donor sites are not there. That's why it is considered as best example of what? Polar aprotic. So in the short form I am writing acetone, and some other solvents are there like DMF, and another one is DMSO. What are these? These are examples for what? Polar aprotic. DMF means dimethyl formamide. What is that? Dimethyl formamide. DMSO means, yesterday we have written dimethyls, 2 methyls, you write like this, 2 methyls, sulfur oxide, like this. In the place of carbon, here you are seeing sulfur, that's it. This is acetone, this is DMSO, just remember like that. These are the solvents. Now, what is this? Here, is there any intermediate? What we are seeing? Transition state. So, transition state, carbon hybridization is sp2. What is the hybridization of carbon? What is the hybridization of carbon in the transition state of SN2 reaction? sp2. Okay, more about that I will tell you while doing the mechanism. Next, look at here. Last one is what point? Here we have written stereochemistry point, racemization I told you. Here in SN2 reaction, inversion, like umbrella inversion you have studied for IP. Like Walden inversion, umbrella inversion, like that you studied. So what is that? Inversion of configuration. What happened? Inversion of, it's fine. Then we'll do the mechanisms. Then it will be giving you more clarity. See. See, there is R. Let us differentiate. This is one alkyl group. Second alkyl group as R dash. Third alkyl group as R double dash. Like this I am taking. So what is the degree of this carbon now? Tell me. See, a group, a carbon atom having 4 different like carbon atom with 4 different groups. What is that called? Carbon atom with 4 different groups. There is something called chiral center. Do you remember? What is chiral center means? Carbon atom with 4 different groups. Okay. It is this. Can I say this is a chiral center? Okay. Just listen here. A points follow ayyaro ledo. Just ikkada follow avandi. Clear unta. First one, in SN1 reaction, halide ion comes out first, or halide ion, or whatever the group here. Let us generalize this as a living group. It is coming out now. So what I am saying, that group as living group. So if living group is coming out, it will take this bond electrons with itself. Now what the charge you are creating here? So Lg minus coming out. So what I should write here? Carbon with 3 different groups now. One is R dash, R double dash. So here positive charge now. It means what is this? It's a carbocation only now. Carbocation or not? So carbocation means what is the hybridization you have? 1, 2, 3. 3 sigma bonds means what is that? sp2 means what is the hybridization? sp2. What is the geometry? Trigonal planar. Like trigonal planar. Yes or no? That's it. This is the intermediate. What is this? Intermediate. So formation of intermediate is there now. This is the main step in the reaction. In SN1 reaction, what is the main step? Instead of saying main step, I should say slowest step. What is the slowest step in SN1 reaction? Intermediate formation. So we are calling this as rate determining step. What is that? Rate determining. So after forming this intermediate, one nucleophile will be there, ma. What is it? Nucleophile. So nucleophile will nucleophile means what they have, electrons they have now, that will be given to this carbocation because it is electron deficient. See, it's a planar molecule I am saying. This nucleophile can come from above the plane or exactly it can come from below the plane. 50-50 chances are there, no? Can come from above or below. So if it is coming from above the plane, we'll get one isomer. If it is coming from below the plane, we'll get one more isomer. The first isomer, second isomer are there, na? Those are called enantiomers. What they are? Enantiomers. This is 50%, this is also 50%. What I am saying, this is 50%, this is also 50%. So the equimolar mixture of two enantiomers is called racemic mixture. What is it? Racemic mixture. So now once again, you just write the product first. C R dash R. So nucleophile I am writing here. See, it is coming from above the plane, no? So we'll get some plus kind of compound. It is also possibility to come from, I am writing minus also. So both of them are equal 50%, 50%, no? So can say this mixture as what? Product mixture as racemic mixture. This racemic mixture, what you should use when the starting material is what? Chiral carbon. What is it? Chiral carbon. Yeah, that's it. So once again tell me what happens in SN1 reaction? Slowest step is, rate determining step is what? Formation of carbocation. Okay. So if this carbocation is more stable, that reaction takes place easily now. Which carbocation is more stable? That's why if tertiary carbocation containing carbon if involving, that will be more easily participate in the reaction. Now see, they will ask you a question like this. Reactivity. See, both alcohols, all haloalkanes combined, we are completing here itself because same mechanism there also. See, for example, I am giving you an alcohol, CH3, 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 OH, CH3, CH, CH3, OH. So out of this A and B, which alcohol readily react with HBr, they will ask. Tell me. HBr means what? It is an acid now. What it will provide now first? H plus. H plus is taken by these alcohols. If it is taking H plus, it becomes water, comes out as a water. If it is also taking H plus, comes out as a water. Now after removing, what is the charge you are creating? Here also after removing this, which carbocation is more stable? A. Tertiary. That's why which carbocation formation is easy? Tertiary is easy. So which means out of these two, which is more reactive in SN1? A. Like this you should say. Reactivity order means. Clear everyone? That's why the first statement 3 degree, 2 degree, 1 degree you have written. Next statement, see. Br, CH3, okay. Now look at this. Which one is more reactive out of these two? With same H. Now I am asking reactivity towards this one, reactivity in SN1 reaction, first one. This one also reactivity in SN1. Which halide ion, which alkyl halide is more reactive, I am asking. How can you answer? Like SN1 means what? Substitution. Substitution means what? Bromide ion should come out, some other nucleophile will enter. So which bromide ion comes out easily and formation of carbocation you check. Which is more reactive, I am asking. What to do? There also I removed water like OH. After removing, what is the charge creating? Here also you remove bromines. What is the charge you are creating? Which positive charge is more stable? First one or second one? How to identify that? See ma, this bromine is removed. What is the charge you are creating? Here also. Which carbocation is more stable? Both of them are secondaries. But how to identify now? Extra thing. Methyl is same. Here it is a methyl group, but here it is a phenyl ring. See, phenyl means how do you will write this structure? Pi electrons are there. See, pi bond, sigma bond, vacant orbital. What happens? Conjugation takes place. Which effect it is? Mesomeric effect. So mesomeric effect is there now. It means carbocation is more stabilized. If carbocation is more stable, then this compound react more. Yes or no? So what you need to check? Stability of intermediate. More stable intermediate, more reactive, that is. Okay. If carbocation intermediate is more stable, then that compound is more readily participating in SN1 reaction. Once again read this. What is the statement? If carbocation intermediate is more stable, then that compound is more readily participating. ఈ రెండిలలో ఏ కార్బోకేటైన్ more stable ma after A compound. So reactivity of A will be more. Clear everyone? Okay. Let us go with little more. See, that's why when I am explaining inductive effect, mesomeric effect, what I told, if you know inductive effect, mesomeric effect, hyperconjugation, you will solve maximum questions without knowing their names also, I told. Why? Because see, if you know the stability order between these two carbocations, you can decide the reactivity order. Okay. Now let's see here what I am writing. CH2Br, CH2Br, NO2, CH2Br, OH, A, B, C. Tell me, once again read this question, this statement and solve this question. SN1 reactivity order. Which reactivity order I am asking? Fast. What to check? Check carbocation intermediate after removing that bromides. Which carbocation is more stable? Fast ma. C is more stable. Why C is more stable? Yes, OH is electron releasing group. Strong mesomeric effect strongly activate the ring. It will stabilize this carbocation. So it means which is more reactive? C. Okay, C. After C? A. Because here electron withdrawing group destabilizes the carbocation formed here. So it means it is least reactive. So, got it everyone? Yes. Let's move forward with SN1 reaction. Together we will study some comparisons later. Okay. Now once again tell me, what is this reactivity order? Primary, secondary, tertiary. Next one is there any intermediate? No. Activity order? What about intermediate? No intermediate. Okay, listen here very carefully. Okay, look at this. same leaving group I am writing here. See, for example, this is nothing but, what is this? Tell me, what is the, order, that one, primary, secondary, tertiary? Primary. So now, what I am saying, X is there now, that is our leaving group. If it is going out, some nucleophile comes in, right now. So, one nucleophile is going out, another nucleophile coming in. So, we can simply say substitution. Here also substitution. Now, what happens is here, when a leaving group is going out, at the same time, simultaneously, this new nucleophile is there now, incoming group is there now, comes in. When it is going out, this will come in at the same time. It means simultaneously happens. What I am saying, simultaneously happens. Okay. See, look at here, halogen means see, halogens are any group. Leaving group means, generally let us say it is a halogen. Halogen means electronegative atom now. Now the bonded electrons are taken by halogen only. So now what is the charge you are seeing on the halogen? If it is coming out, just imagine slowly it is coming out. So now that bonded electrons are carried by halogen only now. Negative charge is there. This fellow, incoming nucleophile, also have what charge? It means this is also electron density, this is also electron density. If they are coming like this, what happens? Repulsions. That's why, in order to avoid these repulsions, hero will enter from back side. From where he will enter? Without disturbing this, he will enter from back side. Okay. Is this clear, everyone? Okay. So now you just need to imagine there is no heroine here. Wait. See, imagine like this. This fellow is living. Which fellow? It will enter at the same time like this. Okay? See, it is leaving, it is entering. So, during this formation, during this transition, how many groups are there on the carbon here? Please look at here. One is methyl group, keep as it is. How many? Array. CH3 is there and one hydrogen. Like that, how many hydrogens are there? Two hydrogens, one methyl group is there. These are perfectly bonds represented, and one group is going out, one group is coming in. Like this. Okay. Now look at the transition state, how it is looking like trigonal bipyramidal geometry. So you can say this transition state has which type of geometry? But what is the hybridization of carbon? 1, 2, 3 bonds. 3 bonds means sp2. So the carbon in SN2 reaction is, what is the hybridization in the transition state? sp2. Perfect. Remember this. Next one, a carbon hold how many bonds? 4. Maximum 4 bonds. Now if you see, 3 bonds are perfect. 4th, 5th bond are also giving electrons. Maximum 4 only, but having something like 5 bonds. It means more electron density and small atom. What it will do now? It will become less stable. Yes or no? Now, in order to stabilize this transition state, what type of groups required to attach to the carbon? Perfect, ma. If electron withdrawing groups are there, that will stabilize this transition state. So, SN2 reaction rate, it means fast reactivity increased by electron withdrawing groups. Clear, everyone? Okay. Next one is, what is that first order you have written? Primary, secondary, tertiary. Sir, why primary first? Because if this group is like this carbon is primary carbon, means see, hydrogens are small groups, Here one methyl group only, they're like little bigger group, remaining all are smaller. So the entry of nucleophile from backside is easy or not? If these groups are also bulky, will they allow this nucleophile to enter? That's why, what is the reactivity order? Clear everyone? Yeah. Next. Finally what happens? This X goes out. And see, if you see X is this side, exactly from opposite plane nucleophile is entered. That's why I have written like this. Like you are carrying umbrella like this. What happens when high wind comes? That exactly that groups goes, that umbrella goes upward. Inversion takes place. Now, same story, you just imagine here the living group is there. That remaining groups are there now. Previously they are like downside. Now what happens? Like that. Same story here also. So you can say this umbrella inversion or Walden inversion. What is that? Umbrella inversion, Walden. Now why we are saying all these things means, you just listen here what I am saying. A carbon is there, hydrogen, deuterium, and some living group I am writing as L, and here one more methyl group, let us put. See, tell me whether this carbon is chiral or not. Once check. 4 different groups are there. Yeah. Now you are treating this with a nucleophile. With what you are treating? Nucleophile. So it is a primary, secondary, tertiary. Which carbon? Only one carbon attached means primary. So primary means definitely SN1. Okay. So this nucleophile is going. This living group is going. Nucleophile comes from backside. So for example, this carbon is having some R configuration. There is something like R and S configuration. If one enantiomer has R, its mirror image have S. Okay, if this compound is having R configuration, this is coming from exactly opposite plane now, the configuration becomes inversion. Inversion means what? R becomes S, S becomes R. So if it is going out, you are going to see something like this, CH3, HD, N, like this. R becomes S, S becomes R. This is what called inversion. What is this phenomena? Inversion of configuration. Fine. Now it is over. Next one. This reaction, if you see, like previously I asked for SN1 reactivity order. So SN1 reactivity depends on what? The statement you have written, no? Carbocation intermediate. So carbocations are stabilized by which type of groups? Releasing groups or withdrawing groups? So you can say if electron releasing group is there, that is favors. Next one, transition state in SN2 is stabilized by? Next, you tell me, this is the order you have written for SN1 reaction. Which reaction? SN1. Now I am asking, for SN2 you tell me what is the answer? B, A, C. Because this is releasing group, this is withdrawing group. Withdrawing group stabilizes transition state now. So that's why B, no group, C. Clear everyone? Perfect. Yeah. Most of our reactions are done. Now you are going to answer this. See. Okay. Before coming to this question, let me show you. Okay. Look at this. Read the question once. Fast. Substrate converting into this product. What makes the change? In the place of bromine we have cyanide. So what type of reaction it is? Like substitution. And tell me whether it is primary, secondary, tertiary. Primary now. So primary substitution means which mechanism? SN 1 or 2? 2. SN2. Perfect, ma. So SN2. Now look at the 4 statements, what they are? Ethanol, methanol, something like they have mentioned. So they are something like, how they are looking? They are something like solvents, na? Solvents only, na? Because nucleophile is given, substrate is given, what we required? Solvent. So which solvent favors SN2? What is that statement I told you? Polar aprotic. So which is polar aprotic? DMF, or this is DMF only. See, DMF, dimethyl formamide. So what is our suitable solvent? 3. Is this clear? How simple? Based on the statements? Yeah. Next one. Next one. They will give like this 4 options. They will give rate of substitution. They will ask substitution reaction. Which is substitution? Nucleophilic substitution. What they will ask? Rate of nucleophilic. So it means which is more easily participate in the reaction. They will say 4 compounds A, B, C, D. Fast. So what to check? If I remove this bromine, substitution means this group should go out now. If it is going out, what is the charge you are creating? Okay, imagine you got this plus charge. What type of system this is? I told you a name for that. Phenyl ring with one CH2 group is benzyl carbocation. Benzyl carbocations are stabilized by these pi electrons. Okay, like this it will be stabilized. Yes or no? Yeah. Next one, here you try to remove this bromine. Remove the bromine. What is the charge you are creating? Phenyl carbocations are highly unstable, I told you, if it is like this. Because previously bromine lone pairs are in conjugation with the ring. Like lone pair, sigma bond, pi bond means alternate position means conjugation. But if I remove that bromine itself, a unstable fragment is formed. Okay, it means will this bromine comes out? It means will the substitution takes place in this compound? No, no substitution in this compound. Okay, next one, look at this, lone pairs, sigma bond, pi bond. Again these are also in conjugation like this. Will this come out now? Array, when there is a conjugation, this single bond becoming a double bond. See, by conjugation this lone pairs comes here means previously one bond. Now second bond also forming by shifting this here. It means more bond strength, like more number of bonds means bond strength will be more now. Will that comes out now? No. So it means this is also won't involve in substitution. Now what about this? You try to remove this bromine. What is the charge you are creating? Will it comes out now? Check once. Positive charge, sigma bond, pi bond. Are they in conjugation or not? So conjugation is there means, see, ఇదేమో తీయక ముందు కాంజుగేషన్లో ఉంది, ఇది తీసినాక కాంజుగేషన్ అవుతుంది. కాంజుగేషన్ ద్వారా ఏమవుతుంది? స్టెబిలిటీ. సో రిమూవ్ దట్, do the conjugation like this. It is stabilizing or not? Okay, so now these systems are called vinyl systems, vinyl carbocation. So if you remember, I told you vinyl carbocations are highly unstable. So it means this kind of systems, will they participate in the reaction in nucleophilic substitution? No, only benzylic, allylic or normal will take part in the substitution reaction, not this benzyl like arylic or vinylic. Okay, is this clear? What to check, ma? Once again tell me. ఏం చెప్పినా చెప్పండి. కాంజుగేషన్. సబ్స్టిట్యూషన్ అంటే ఏంటి? ఒక గ్రూప్ బయటకు వెళ్ళాలి, ఇంకో గ్రూప్ లోపలికి రావాలి. ఈ గ్రూప్ బయటకు వెళ్ళేటప్పుడు దాని యొక్క స్టెబిలిటీ చూసుకోవాలి. ఇఫ్ యు ఆర్ రిమూవింగ్ దిస్ బ్రోమిన్, వాట్ ఈస్ ద స్టెబిలిటీ ఆఫ్ దిస్ కార్బన్? You check. So if you remove this bromine, positive charge you are writing, check for its stability. Benzyl system will stabilizes. So perfect, no issues. But if I remove this bromine, first of all it won't comes out. Why it won't comes out? Because lone pairs electrons are in conjugation. ఇక్కడ ఇది కాంజుగేషన్లో ఉందా? అవి ఎలా ఉండాలని చెప్పిన ఫస్ట్ ఈ లోన్ ఎప్పుడైనా కాంజుగేషన్ అంటే ఆల్టర్నేట్ పొజిషన్లో ఉండాలి. పై బాండ్, సిగ్మా బాండ్, లైక్ లోన్ పేర్స్ అయినా ఉండాలి, నెగటివ్ ఛార్జ్ అయినా ఉండాలి, పాజిటివ్ ఛార్జ్ అయినా ఉండాలి. బట్ దిస్ వన్, దిస్ సిస్టమ్ సపరేటెడ్ బై హౌ మెనీ సిగ్మా బాండ్స్? 2 సిగ్మా బాండ్స్ అంటే కాంజుగేషన్ ఉన్నట్ట? లేదు. హౌ మెనీ సిగ్మా బాండ్స్ షుడ్ బి దేర్? So that's why this one and this one are not in conjugation. But after removing this, I am generating a positive charge. Now positive charge, sigma bond, pi bond. It means this is conjugative system. Clear? Okay. Now, before removing, just check for the conjugation. Lone pairs, sigma bond, pi electrons. Conjugation is there. If conjugation is there means single bond become double bond. It means will it come out now? No. That's why aryl halides won't involve in substitution reactions. This one vinyl, like see, pi bond, sigma bonds, lone pairs. Are they in conjugation or not? So this will also won't involve in substitution. Now check lone pairs, sigma bond, sigma bond. Are they in conjugation? Check once first. ఎలా ఉండాలమ్మా కాంజుగేషన్ అంటే? పై లైక్ ఆల్టర్నేట్. సి లోన్ పేర్స్, సిగ్మా బాండ్, again sigma bond, then pi bond. Is this alternate? If they are like this means is this is alternate? No. If not alternate means there is no conjugation. Now try to remove this now. Remove, after removal what is the charge you are creating? Positive charge, sigma bond, pi bond. Now they are like conjugation. So now conjugation is there. Okay, it will be stabilized by carbocation rearrangement like this. I mean conjugation. So allylic will participate, benzylic participates, but vinylic and arylic will not participate in substitution reactions. Okay. Now look at this question. Once read that. Organic halides which does not undergo hydrolysis by SN1 mechanism. SN1 mechanism means what is that we need to check? Stability of, like tertiary is fine, but what is that statement I told you? Stability of carbocation. SN1 means stability of carbocation. So carbocation stability after removing this chloride you check. Positive charge. Will it be stabilized or not? You check. Stabilized by pi electrons. Perfect. What about this one? You remove this chlorine. Positive charge here. Will it be stabilized or not? By this pi electron, sigma. So conjugation. Perfect. Okay. Now what about this one? See, 3 carbon with 3 alkyl groups, 1 chlorine. If I remove this chlorine, you get a positive charge. How many alkyl groups are there? So what is this carbon called? Tertiary carbocation means readily involves this one also. No. Now what about this? What about this? Try to remove this chlorine. Will it involve in any conjugation after removing? Before removing you check. Chlorine, lone pairs, sigma bond, pi bond. How they are? Alternate. Before removing only they have conjugation means will it comes out now? If it is not coming out means will that enter in? ఇది బయటకు వస్తేనే కదా అది లోపలికి వచ్చేది న్యూక్లియోఫైల్. సో ఇట్ ఈస్ నాట్ కమింగ్ అవుట్ మీన్స్ విల్ ద సబ్స్టిట్యూషన్ టేక్స్ ప్లేస్ హియర్, విల్ ద హైడ్రాలసిస్ హ్యాపెన్స్ హియర్. సో వాట్ ఈస్ అవర్ ఆన్సర్? డి. సో సి వాట్ టైప్ ఆఫ్ సిస్టమ్ దిస్ ఈస్? an sp2 carbon. ఈ కార్బన్ ఏంటమ్మా? sp2 carbon. If any halogen is there, that carbon is called, like double bond is there means that is called vinylic. What is that carbon? Vinylic. So vinylic and arylic compounds does not involve in substitution, whether it can be SN1 or SN2. So what is our suitable answer for this? Okay, done. Okay, now what is the solvent favors I told you? SN1 polar protic, polar aprotic. Next one, let us compare with the elimination reactions. See, one more mechanism is there. Now whatever you have studied till now, that is about substitution. Which substitution? Nucleophilic substitution. Next one is elimination reactions are there. Eliminations in the last class also we have studied. C X H CH3 like this they will mention for elimination. See, halogen attached carbon is called what? Alpha carbon. What is that? Alpha. Adjacent carbons are called? Beta. How many beta carbons are there now? 2. Now that halogen atom and that beta hydrogen are removed, and here if you see 2 beta hydrogens are there. This is beta, this is also beta, but out of these 2 I can only remove one using this H and this X and this H. Okay, out of this which is removed they will ask. You should need to remove that proton which is trans to this halogen. Trans means what? Like opposite direction. These are opposite now, so you should need to remove this one, not this one, in elimination. So this base will take this proton, this base OH minus will take this proton, this bond will shift here now, and halogen atom comes as halide ion. So now what is the remaining thing, tell me? CH3 here, this one C, one hydrogen, double bond, CH, CH3. So what is formed in elimination reaction? Alkenes are formed. What they forms? Alkenes. Yesterday also we discussed in the preparation of alkenes case. Okay, I told you something like shades of product, Hoffman product. Okay, next thing is, here also 2 types of mechanisms are there. E1 mechanism, E2 mechanism. What is that? E1 mechanism, E2 mechanism. In both of this reaction, that order of reactivity is there now in substitution. What you written? 3 degree, 2 degree, 1 degree, 1 degree, 2 degree. Here for both this reaction it is 3, 2, 1 only. For both of them. Okay. Next one, here in E1 as like SN1, here carbocation intermediate is formed. What is formed? In E2 there is nothing like carbocation intermediate. Here same like SN1 means what is intermediate you seen? In E1 also what we have? In E2 there you have seen transition state now. Here also transition state. So it means E1 is multi-step, E2 is single step. Okay. Next one. See, I am saying multi-step, single step now. Like whenever I say SN2 reaction, rate of reaction depends on that substrate as well as nucleophile, because both of them are involving transition state. So that's why what is this 1 and 1? Total how much? 2 now. So it means that's why you are writing here 2. 2 means what? Bimolecular nucleophilic substitution. In that rate determining step, how many particles are involving? One substrate, one nucleophile. In which mechanisms? That is in SN2. In case of SN1, what you have seen? Only in rate determining step, what is involving? Only substrate. That nucleophile involving? No. So that's why rate of reaction depends only on what? Substrate. So only one now, nucleophile not involving. So that's why what is the order of that reaction? 1. So here also E1 means only substrate, not base. E2 means both substrate, base. That's it. Next one. When is shades of product? When is Hoffman product? I told you. If small base, which product? Shades of product. Bulky base or weak leaving group? Hoffman. Okay. Now I told you yesterday about solvent also. Sir, how can we segregate like substitution or elimination? Depends on solvent, I told you. So solvent, what it will favors? If you are taking aqueous media, This will favor substitution. What is that? Substitution. If you take alcoholic medium, it will favor elimination. It means with one simple example I will show you. See here. CH3, CH2, CH2X, Br. Aqueous KOH, alcoholic KOH. They will mention like this. Now tell me, what is the product formed in first case and second case? Aqueous KOH means, aqueous means water only, no? So you have water molecules with K plus and OH minus. So what is the thing you have here? OH minus only. Here it favors SN, 2 real. See, whether, tell me this is primary, secondary, tertiary? Primary. Definitely substitution now. Primary means which substitution? That's it. Next one here, alcoholic KOH I am saying. Alcoholic means, let us say you take ethanol. Ethyl alcohol is there. And what other thing we have? K plus OH minus. So this OH minus ion will take this proton now. What happens now? Ethoxide ion plus H2O potassium. See, when I say alcoholic KOH, my base is ethoxide ion. So this is stronger base than, like stronger base than OH minus. That's why alcoholic KOH act as a basic medium. How it will be? It is a basic medium or base. If I take aqueous KOH, it will act as a nucleophile. What is that? Nucleophile. So nucleophile base means what the difference? Base means it will take the proton. If I say nucleophile, it won't take proton, it will replaces this. So what it comes out now? Bromine comes out and write remaining thing CH3, CH2. What is the nucleophile we have in this? OH. That's it. This is your product. Here what happens, tell me? This is alpha carbon, beta carbon. So alpha beta elimination, from beta position what it will abstract? A proton, and this halogen comes out, CH3, CH, double bond, CH2. So what it is happening in the first step? First reaction? Substitution. In the second reaction? How to identify now? Look at the solvents. Aqueous KOH means? Alcoholic KOH means? Elimination. Remember this. Okay. Again they mention also heating conditions. For which one? See, if we increase the temperature, both SN1 rate increases, SN2 rate increases. But rate increased in elimination, I mean SN1 rate increases, elimination rate increases. But increase in rate will be more for elimination. That's why high temperature favors which reaction? Elimination over the substitution. Okay. Right. Now let us see some questions on this. Okay. Tell me, ma, what is the product formed here? Tell me, what is the mechanism? Substitution or elimination? Perfect. Elimination. Which elimination? Br will go out. So, where double bond? Inside or outside? Like this? Perfect, everyone? Okay. Next one. Instead of using this small, this one, I am using this one. What is this? Plus means? This is methyl groups. How many methyl groups? 3. Here one more carbon is there. 1, 2, 3, 4. 4 carbon means butyl, tertiary butoxide ion you should say. What is that? Tertiary? So now this is small base or bulky base? So now what happens? What type of product formed? Half month. It means what type of alkene it is? This side. That's it now. Look at this. If I use a small base, I will get shades of product, more substituted. See, more substituted alkene. How much percent I got? 79. And 21% this one. But if I use this bulky base, the story is opposite. Bulky base, which product is major? No, half mole. Do you got the concept what I am saying? Yeah, look at the base size, decide your product. Okay, next one. See, they will mention like this. Substrate they will give, simply they will mention water. So what happens? Bromide ion comes out, water means OH will be the incoming nucleophile, alcohol will be the product. If they mention like just heating, heating means what? Elimination. So you just remove this bromine with one beta proton from here or here, you will get respect to alkene. Okay, right, next one. See ma, here if they mention simple OH minus or aqueous OH minus ion, what happens? Bromide is replaced by OH minus. Substitution takes place. If they mention like alcoholic like ethoxide ion like that, elimination. Yeah, perfect. See what is happening in the reaction? First,
Elimination.
Elimination. Particularly which type of elimination they will ask? No. Whatever the options are there, you will say from there. Are elimination antunnara, SN2 antunnara, endi this? Which one? Are E2, E1. Here you will get the basic difference. Okay, heating will get this. Okay, so rate depends on what? Concentration of substrate, and also here elimination we are saying now, so don't say nucleophile, you should say base. If it is depending on both of this, rate is depending on both of this means what order is? 1 and 1 means 2, that will be E2. But if you see, there is just alcohol, there is nothing like base, OH minus or something like this to abstract this proton, or there is nothing like ethoxide ion like this. If nucleophile is mentioned stronger, then you should follow, see, base rate is depending on base means which reaction? E2. Here does this base is doing anything? No. First this chloride ion comes out, positive charge, then next this alcohol will take this proton. It means its activity is very less, ante deen participation takku undi. First ఇది వెళ్ళిపోతుంది, పాజిటివ్ చార్జ్ క్రియేట్ అవుతుంది, we are heating, that's why this proton is removed. So it is not depending on concentration of base, not depending on concentration of base means that rate is depending only on substrate concentration. So now what is the order? E1. That's it, 1. So it is E1 mechanism. So what is your answer? C. Okay, tell me what is your answer for this fast? Fast. See, elimination or substitution?
Elimination.
From where I should remove that? This side or this side? Inside or outside?
Inside.
That's it. So where do we have? First answer. Is this clear, everyone? Next. Answer me this fast. Transitions. Second one. See, what is that they are saying? Rate. SN2 reaction means rate depends on what? Substrate. That's it. Like this you write first. Next statement what they are saying? If we double the concentration of, it means this reactant is becoming doubled. It means 2S. And also nucleophile also, if we double the concentration of reactant, and this is also becoming 2 nucleophile. So this is 1, this is 2. So now if I want to write second one like R1, R2 let us say. R2 means what I can write now? R2 is equals to 2 2s are 4 S Nu. Instead of writing this, I can write R1. So R2 becoming 4 times of SR now. So what is your answer? That's it. That's it. That's it. So this is about the first chapter, that haloalkanes chapter. Next, alcohols we'll see. Okay. If one OH is there means like ethanol, methanol, that we all know. If 2 OH groups are there, like the best example is like ethylene glycol. What I can say, ethylene glycol, or simply it is called as glycol. Okay. And if 3 are there means glycerol or glycerine will be say. Okay. Now you need to remember these common names. Phenol means you know. If one OH and one CH3 is means cresol. If they are ortho to each other, 1, 2 position, orthocresol. 1, 3 metacresol. 1, 3 meta. 1, 4 paracresol. Okay. If 2 OH groups are there, catechol, like 1, 2 positions are there now. What is that called? Catechol. 1, 3 position means resorcinol. What is it? Catechol, resorcinol. 1, 4 position means quinol. What is it? Hydroquinone or simply quinol. What is it? Quinol. They will ask you to match. Tell me what is resorcinol? 1, 3 OH groups. 1, 2 catechol. 1, 4 quinol. Yes. Okay. In the last class, when we discussed about alkenes chemical properties, there we studied hydroboration reaction. What happens in hydroboration? Tell me. Alkenes, cheppandi. Alkenes with borane in basic medium gives you alcohol. Product formed will be similar to anti-Marconi rule product. Okay, like that you have written some statements. Now see, this is symmetrical or unsymmetrical alkene? So where I should add OH, where I should add H? A, B, C. Tell me. ఏంటి మార్కోనిక్ ఆఫ్ రూల్ యాంటీ మార్కోనిక్ ఆఫ్ రూల్ ఒక్క రోజుకి అయిపోయిందా? వేర్ ఐ షుడ్ రైట్ కార్బన్స్ కంటైనింగ్ లెస్ హై part. So you just need to add one H and OH. Where I need to add H and OH? Will this involve in the reaction? No, don't disturb this. Only here only. Tell me. AOH. Perfect. BH. That's it. Okay. See, one BH3 unit. How many hydrogens are there, ma? 3 hydrogens are there, na? Each time you give one hydrogen to this. Like that, how many alcohols can react with one BH3 unit? 3. So 3 alkenes react with one BH3 unit. Finally, you will get 3 alcohols. How many alcohols? 3 alcohols. Each time you are taking one H now. You take one H. Like that, how many H you are taking? 3. You give OH. How many OH? 3 OH. So what is that byproduct formed? H3BO3. Remember this. Okay. Next one. This H I am saying now, I am adding one H and OH you are saying. This H comes from this diborane. From where that H comes from? Like this BH3 unit is there now. From there this H comes. This OH comes from here. H2O to OH is there now. From there this oxygen will come. Clear everyone? Okay. Now tell me again for this. Yesterday we have written. Anyways, I wanted to test you once again. B2H6 NaOH H2O2. Tell me, what's your answer? Tell me, where I should add H? At this methyl group, what I should add? Tell me now. AB. A daggara? A daggara. A daggara. B daggara? That's it. Cis addition, syn addition, I told you. It means both the groups that you are adding should be in the same plane. Done. Done with the hydroboration. If I do hydroboration in acidic medium, what is the product formed? In basic medium, it is alcohol. In acidic medium, it is alkanes. What they are? Alkanes. Next one. OM-DM reaction. What is that OM-DM? Oxymercuration, demercuration. After this, you read written once. Check. Like product formed will be how it looks. Like HgOAC they mentioned, H2O, NaBH4. Tell me, where I should add H and OH? This is called OM-DM. 1, 2. That is reverse to this. Here it is Marconi Caffrol, it is anti-Marconi Caffrol, here it is Marconi. So CH3, CH, CH2, OH here, H here. Here I told syn addition, cis addition, same side. This is opposite side addition. Okay, mechanisms I am not explaining because at this time remembering reactions only difficult. If I say mechanism, you feel exhausted. Okay, these tricks are enough. Like hydroboration means what happens in basic medium? Alcohols forms. Formed product will be similar to anti-Marconi Caffrol product. Okay, wherever double bond is there only you put one OH and H by following anti-Marconi Caffrol addition. If I have OM-DM reaction, follows Marconi Caffrol. No rearrangement, wherever double bond is there, on one carbon you add OH, other H by following Marconi Caffrol. Next. That's it. This is a mechanism, all these things is not required, no? Okay. Tell me, once you answer me this, is it cis addition or syn addition? Cis addition or trans addition? Hydroboration means what? Syn addition only, now. It following. What we are adding finally? H and OH. It means water only we are adding. Next one you tell me. What is a byproduct? Just now I told you. Next one. Follows anti-Marconi Caffrol. This one? Correct only now? Yeah. This is also correct. A, B, D. Yesterday I told you about how this Bayer's reagent will react with alkenes. What I told you? If there is double bond, treating with Bayer's reagent, what happens, tell me? Alcohols. Which type of alcohols? I told you to remove double bond, place one OH here, cis diols is formed. It means CH2, CH2, OH, OH, that's it. Okay, same osmium tetroxide also same product. Okay, remaining things will continue in the next session or in the study hours also. So you take break, that's it.